Culminating our video series on exponents, let's take a look at some problems that combine all of our exponent rules into one. Now please realize that as we do these problems that there are multiple ways of solving the problems contained in this worksheet. So we're just showing you one approach. And the approach that we're going to take here is we're going to try and do our best to simplify what's in the parentheses first before handling any exponents outside. You could do the reverse, but that's just the choice that we've made here to keep the numbers sort of simple and be able to deal with them that way. So let's start with question number 1. What I mean is we're going to take care of this fourth power as our last component. So we're going to take care of what's inside the parentheses first. And we're going to apply in all of our rules of exponents all combined into one problem. So let's start with the inside. Only looking at the inside, we have x squared divided by x. They're being divided. They have the same base. And so we should take the exponents and subtract them. So we have x squared divided by x to the first. 2 minus 1 gives us x to the first power. The same thing with the y's. So y to the fourth divided by y to the second. We'll take the exponents. They have the same base, so we'll take the exponents and subtract them. 4 minus 2 gives us y to the second power. Now don't forget, this is all to the fourth, so let's handle that now. We have an expression taken to an exponent. We have exponents taken to exponents. And so we'll take each piece of the expression and take it to the fourth power. So x to the first to the fourth power and y squared to the fourth power. Now we have exponents to exponents, which means we should multiply those exponents together. X to the first to the fourth, 1 times 4 gives us x to the fourth. Y squared to the fourth gives us 2 times 4, which is y to the eighth, and there's our simplified expression. In number 2, we're going to do the same thing. We're going to take care of what's inside these brackets before we handle this squared part. So let's take a look inside here. We've got 4a cubed b to the fourth. That's all cubed. So we'll take the entire expression and cube it. We'll take 4 cubed. We'll take a cubed and cube it. And we'll take b to the fourth and cube it. Keeping in mind that this is all still to the second power. 4 cubed we know is 64. A cubed to the third power. We have exponents to exponents, so we'll multiply to give us a to the ninth. And the same thing for b. So 4 times 3 is b to the 12th. We still have to square that at the end. 64. Oh, once we have everything inside handled, we're going to take care of that squared power. So we're going to square every single piece of this term. So we'll do 64 squared. We'll do a to the 9th squared. And we'll do b to the 12th squared. $64 squared, probably don't know that off the top of our head. So we'll type it in our calculator, and we get 4,096. A to the 9th squared, exponents to exponents again. So we'll multiply those together. 9 times 2 is 18. And finally, b to the 12th squared, we'll multiply the exponents together. 12 times 2 is 24. And there's our answer for number 2. Let's take the same approach to number 3. Let's go ahead and simplify what's inside the parentheses first before handling the cubed. So we're going to divide this time. 6 divided by 8. 2 goes into both of those, leaving us with 3 fourths. We have m to the fourth and n to the sixth. There's no matching bases, so those will stay separate. And then now we'll handle our cubed. Remember, we have to take every single piece of this term inside the parentheses to the third power. So we'll do 3 cubed. We'll do m to the fourth cubed over 4 cubed and n to the sixth cubed. Scoot down just a little bit so we have a little more room to work. 3 cubed, of course, is 27. M to the fourth to the third, powers to powers, means multiply the exponents. So m to the 12th In the denominator, we have 4 cubed, which is 64, and we have n to the 6th to the 3rd, power to power, multiply the exponents, gives us n to the 18th. Moving on to number 4, we'll do the same thing. We'll handle the parentheses first. There's nothing to do particularly inside either set because we have nothing with similar bases. So let's just handle this cubed right here first. I'm going to rewrite 4a cubed b to the 4th. No change there. We're multiplying that times a cubed b squared all to the 3rd power. We've got this big term inside being cubed, so we'll take every piece of it and cube it. So we have a cubed, and b squared, cubed. Simplify from there. We still have 4a cubed b to the 4th, no change there. In the second piece, a to the 3rd, power to power means multiply the exponents. 3 times 3 is 9. B squared to the 3rd, multiply the exponents to get b to the 6th. At this stage, we do have things multiplied with the same base. The 4 is still by itself. We have a cubed times a to the 9th, same base being multiplied, so we'll add the exponents, a to the 12th. Same thing for b to the 4th and b to the 6th. We'll add the exponents to give us b to the 10th. Problem number 5, we're going to handle inside the parentheses first. Nothing to do there though, because we just have m squared n to the 4th. So we're going to handle this to the 8th power to start. Since we have an expression all to the 8th power, we're going to take each component of it and take it to the 8th power. So m squared gets taken to the 8th power, n to the 4th gets taken to the 8th power, and then we still have n squared in the denominator. M squared to the 8th power, power to a power, means multiply the exponents, so m to the 16th. N to the 4th to the 8th power, we're going to multiply the exponents to give us n to the 32nd, and then we're still dividing by n squared. Now we're dividing two things with the same base. The n's are the same in n to the 32nd and n squared. When we divide things with exponents, we subtract those exponents. M to the 16th remains, and then n to the 32nd divided by n squared, subtract the exponents. 32 minus 2 gives us n to the 30th. Last but not least, number 6. We said we're going to try and simplify what's inside the parentheses first, so let's do that. We'll handle this cubed a little bit later. Let's start with the numerator. We've got an entire expression, x cubed y to the 5th, all taken to the 3rd power. So let's go ahead and take each component and take it to the 3rd power. So x cubed to the 3rd power times y to the 5th to the 3rd power. The denominator remains x to the 4th y squared. Don't forget about the big cubed. We'll get back to that later. Handling more of the inside of that cubed, we can take a look at the numerator and notice we have x cubed to the 3rd power. Exponent to an exponent says to multiply, so x to the 9th. And y to the 5th to the 3rd power, multiply again to give us y to the 15th. That's still over x to the 4th, y squared, and we're still going to eventually cube the entire expression. Let's start to handle the inside some more. Now we're dividing. X to the 9th divided by x to the 4th. They have the same base, so we'll subtract the exponents to give us 9 minus 4 is x to the 5th. The same thing with the y's, so 15 minus 2 gives us y to the 13th, and it's still all cubed. We're finally ready to handle that, so let's take the entire expression inside the parentheses and cube it. X to the 5th gets cubed, and y to the 13th gets cubed. We have exponents to exponents. We multiply those exponents together. X to the 5th cubed is the same thing as x to the 15th, 3 times 5. And y to the 13th cubed is the same thing as y to the 39th, 13 times 3. And that's our answer for number 6, and the end of our video series on exponents.